Okay, so I always say this, famous last words, not a whole lot to go over today. But this is where we left off with, and why do alkenes have more isomers than alkanes? Because you can move that double bond, that's right, okay? So when we look at this, we say butene has 3 structures. What would they be? Well, here's one. Move the double bond to 2-butene, and then 2-methylpropene. That's right. Okay, so that would get us caught up to where we had left off. And then, like I said, the naming is, of course, as we can see, very similar to that of the alkanes. So we're just going to write this down, go over some names of some compounds, and then that will be it for today. Because I suppose you could say maybe we need to pace ourselves because this chapter is just so big, because it contains these, I like to call them aliphatic carbons, okay? And we'll make sense of that here in just a moment. Why it's aliphatics. And then sometimes it's just amazing when you make that good of material, and now you've got your stress ball, you say, and do you think, I made that? That's so satisfying, maybe? Okay. Right on. Okay. So, therefore, the reason we call these aliphatics, I guess we don't need this anymore. Okay. Would be yeah, we won't make this that incredibly challenging. We'll just do this then. Okay. The reason we call these aliphatics is because we're not even halfway through. Because when I say this chapter is so big, does anyone recognize that compound? Benzene. That's an aromatic compound. So this chapter doesn't just include the alkenes, but it also has the aromatics and the reactions that would accompany those. That's why setting the stage for what you learned last chapter with those reactions is so important to apply this chapter. Okay, so we say that nothing's changed. Okay, your parent chain has a prefix of what? Okay, so it's got 6 carbons. So then now we know our organic family, and of course once we write that, we know that somewhere there's got to be a double bond. Okay, and with that, the double bond is what takes the priority over as far as where these derivatives are located. Since this is our organic family, that has to have the lowest number. Okay, that's why we thought, well, what would happen if we moved that methyl group over here? Well, then that number is going to be large because we can't change the number for that, because that has to have the lowest combination. So with that, To give the lowest combination, do we go left to right or right to left? You could do either, okay? But what might make that a little more clear? Yes, you're right when you could say this way, it's after the third carbon. That's correct. If you go this way, it's after the third carbon. But what might be our deciding factor? Yes, because we want these to have a lower number, okay? Then, once we've established that, okay, which one is written first? Okay, and that's on which carbon? Okay, so that means we've got 3-ethyl dash what? Okay, 2-methyl. Dang, I was going to start right here. I thought, well, I might run out of room. I'll just see if I can fit it in there. Oh. Okay, so what have we not accounted for yet? Okay, and that number would be what? Okay, that's correct. If there's nothing written after a number, it's telling you one of two things. Either where, I suppose you could say it's saying the same thing, because this means your organic family, that there's a double bond somewhere. And that's telling you where it's at after the third one. Okay. So we will get more into naming some of these compounds and see, I think, and cis and trans compounds. We will get to those on Friday because tomorrow we are, as you know, next door. Repeating the process that you had done yesterday. Fingers crossed. Who is optimistic that you can make the same product? We'll call it slime, but are optimistic you can make that same product tomorrow that you did yesterday? Okay, it could depend on some certain factors. If they follow directions or whatever. Okay, that's all I have. We'll catch up to you next time.